This is Year 13 AS1, and these are a selection of questions based on physical quantities from past paper questions from 2004 to 2009. So the first question in the booklet was from January 2004, and it's a question 3. It says any vector may be resolved into two perpendicular vectors. Figure 3.1 shows the vector v, which makes an angle theta with the x-axis. So write down the magnitudes of the x and y components of this vector. So if we are to draw a right-angled triangle, as I've taught you to do, which meets the vector v, then your r's are going to go like that and like that. The vector component beside the angle here is v cos theta, and the vector component opposite the angle here is v sin theta. And so our x component answer then is v cos theta and v sin theta. Part B, the displacement vector SBL of London L from Belfast B is 500 kilometres in the direction 40 degrees south of east. So there's Belfast, there's London, 500 kilometres, a direct distance of 500 kilometres along there. The diagram's not to scale. The next part of the question then says, an aircraft flying from Belfast to London actually takes a two-leg flight path. It flies first of all east, and it's represented by this vector SBW, and then it flies at an angle towards London. And the second leg is represented by the displacement vector SWL of magnitude SWL in the direction 5 degrees south of east. So there's east, so that's south of east. It says then, show the magnitudes of the components of SBL. So there's SBL there. Are to two significant figures, 380 kilometres due east, which is this direction, and 320 kilometres in the due south direction. So I'm going to just draw over the top of this, and I'm going to draw the two components of this of this line here, which is SBL. So if I continue that across there, and then down to where it meets the L, in a right angle triangle as we would normally do, and then put an arrow in each one. They always follow each other round and meet the resultant vector, which is a 500 in this case. Then you should be able to see quite clearly that this is going to be, because we've got 40 degrees here and this line is opposite, then this is going to be 500 times the opposite side then involves sine, so it's sine of 40 degrees. And this side is 500 times the cos of 40 degrees. So we're just going to prove that those two lines then, or the sizes of those two components are equal to 380, this one here, and 320. So if I just do that on the next page there. So east is the one which is, just check that again, 500, the cos of 40, and then south is equal to 500, the sine of 40. So the east comes out to be equal to 383 kilometres, which is approximately 380, of course, and the south direction comes out to be 321. There is an alternative, and the alternative is that you could have just shown that you could have proved Pythagoras' theorem using those numbers. So the hypotenuse of the triangle would have been 500. We'll just draw that out very briefly. They're suggesting that the hypotenuse would be 500, that this would be 321, and this would be 383. So if that was true, then 500 squared should be equal to 383 squared plus 321 squared. Square root of the whole thing. And that is true, that is the case. It then says, hence calculate SWL and phi. So if we just go back to the original diagram again, we now know that the length of this side here is 500 times the cos of 40. So we need to know, we're trying to find this magnitude of this here. We know that this one here is 321. So we need to find the magnitude of this little bit here. We know the whole thing is equal to 383. And we know this bit's 160. So the bit that you're missing there, if we just draw that in then, is equal to 383, take away 160. And that comes out to be 223. So this side here is 223. We know that this side is 321. And therefore we're trying to find the magnitude and this angle phi. So the magnitude is equal to 321 squared plus 223 squared, and then the square root of the whole thing, and it comes out to be 390 kilometres. Phi then, to find this angle, we know these two sides here, so we'll use tan of phi, and it's the opposite, which is a 321, divided by the adjacent, which is 223, and it comes out to be 55.2 degrees.